morning class. How are you doing, all of you? Yesterday we were doing completing the figures for a given lines of symmetry. Now today, in continuation with that, few of the parts were left. So we start with those questions only. We were at question number 12 and part D till C we had done it. Now the line of symmetry you can see is like this. This is the line of symmetry and the figure given is 1 centimeter horizontal, then 2 centimeter diagonal, so 2 centimeter almost diagonal, then 2 centimeter vertical. So now you have to complete this full figure so that the symmetry happens along the vertical line and symmetry happens along the horizontal line. So we start from horizontal line. First we will complete 2 centimeter vertical, then 2 centimeter diagonal and 1 centimeter horizontal. Then we will go to vertical line of symmetry. This is when you fold it, it would look like this. Now the vertical line of symmetry, 1 centimeter, horizontal. Then you have 2 centimeter vertical, then 2 centimeter vertical below the line of first line of symmetry, then 2 centimeter and 1 centimeter here. So with this you get the full line of symmetry in this case. So this is the figure completed around the two lines of symmetry. Then you have next figure, which is again two lines of symmetry, vertical and horizontal, and the figure is one horizontal, then one vertical, then horizontal, then two vertical, and then one diagonal. So completing the figure along the vertical line of symmetry, we would get one diagonal, then two vertical, then one horizontal, and then the vertical. So in this way it would complete. You would do it on the square paper. Then we coming to below. For the horizontal line of symmetry, we would get first the vertical, then one horizontal, then two vertical, and then the diagonal. Similarly, wait a minute, here the symmetry has become long. So this is the line of symmetry for question number 13, first figure. you have to complete the figure and show the line of symmetry so that it looks symmetrical. Then second part is, there is a line, you have to draw the figure first. It's like this, then this. So how would you complete the figure here? We would draw the figure and complete it like this. Then the third part, you have been given so this is how you would complete first this, then the vertical line, and so a bit of unsymmetry is there. Let's draw it again. First you will draw then the vertical line, and then complete the figure like this. Your line of symmetry would be this one. So this is the figure completed. Then the fourth part, you have 4 centimeter dots. 4 dots are joined, then 1 centimeter down, and then 4 centimeter 4 dots diagonally. So we make the dot 4 dots diagonally. So now you have to complete this figure. So but how would you complete? First the 4 centimeter like this. This is your line of symmetry. Then 1 centimeter down, and then four centimeter down here, and this also we would make it 4 centimeter down. So it would be like this. So this is our complete figure. Then fifth one is 2 dots, so 2 centimeter here and 3 dots here, so 3 centimeter here. So how would you complete the line of symmetry? you would have 3 dots here. We make this as a line of symmetry. So 3 dots this way and complete the figure 2 dots this way. So you get the line of symmetry. This is the line of symmetry. Then the last figure, you have 2 dots horizontal, then it is connecting 2 dots, leaving 1 box in between. Then you have a line like this. Now you have to complete the symmetry. So what would be your line of symmetry in this case? We can make the line of symmetry like here. We can make the line of symmetry here. So first the horizontal 2 dots, then we have somewhat like we make it here. And this line would go forward and join it here. So this would be, this is a bit different. So first we have to make a line like this. Or we can change the line of symmetry also. Like in this part, what we can do is change the line of symmetry. It is like here, then down here. So we can make the symmetrical around the horizontal line of symmetry. So we would get the figure like this. You have to look carefully that how the figure can become symmetrical. So this is the symmetry that we get. So this is the line of symmetry. Now we move to, so with this the exercise is complete. And now we have the next exercise, which is the rotational symmetry. Line of symmetries divide the figure into two exact patterns. The only thing is that they overlap each other but are reflection symmetry. Now next is the rotational symmetry. Rotational would include the angles and not the lines. So you know what is angle now. So when we were doing the rotated square method, what we were doing, that you can have a square, like this, but on a dot paper we also did what, that we rotated this square and drew it like this. We rotated or make it inclination, made an inclination like this. So this way also you get the rotation. So this, now here you say that square is rotated to some angle. Now what would be the symmetry? You can see here that when square is rotated like this, it is making certain angle here. The side of, if I name it A, B, C, D, so you say that this is A, B now, C and D. Now AB here is horizontal and AB here is at certain angle. I can make an angle here. It has been rotated anti-clockwise. So these figures we drew on a dot paper. So now you can here see that this figure is not exactly like the first figure. When would this figure become exactly like the first? If I rotate AB further, okay, I rotate AB further and make it further rotation. So like you would have a total rotation, like let me make the rotation first. So this is the, now here this is AB and this is CD. So what can you say about first figure? This is first figure, this is second figure, and this is third figure. What is the difference between first and third? Here the AB is horizontal, here the AB is vertical, here CD is horizontal, CD is vertical. But if I don't name it, I remove the naming, then what can you say about how does they look like? They look similar, okay? Both of them are looking similar. But the middle one, the second part, it is not looking same as the first figure. So that means when you rotate a figure to certain angle, such that when we rotate a figure such that it exactly looks like the original figure, then you say that then it is said to have rotational symmetry. Okay, so here the what has been done, the if I name it again, AB here was horizontal and now AB has become vertical. So how much AB has been rotated? Can you guess? First AB was like this. If I draw AB here, this was like this, and now AB has rotated to become the vertical line, standing line. This was sitting line. So how much rotation has taken place? It is total of 90 degree. This is making L shape. So it has been, you can say that square has been rotated 90 degree or at right angle. Always remember 90 degrees right angle, and we get a rotational symmetry. Okay, so here you get the rotational symmetry. So what is the angle of rotation of symmetry? Angle of rotational symmetry becomes is 90 degree. When you move the square to 90 degree, rotate the square, not move, rotate the square to 90 degree, then it becomes a rotational symmetry. It appears same as the first one. Now what I can do is, I can again rotate it a bit. If I rotate it again, then how would my square look like? Now I am rotating it not 90 degree but less than 90 degree. So I will get so again I rotate AB. So now AB has become, it is B and this is A. Okay. Or you can say that this is A and this is B. I have rotated it like this. Again the figure do not match the original figure. So you can say, you have to always compare with the first figure. It doesn't match. So you would say that again there is no symmetry. No symmetry here. Now in the next one, next figure, what I would do, I would further rotate the figure and make it a square again, but this time while naming the square I would get A here, B here, C here and D here. So from the original figure, when AB was at the bottom line, now AB is at the front line. So in this way again there is a symmetry. Now how much I have rotated between these two? Again, if I see the third figure, AB was vertical, now AB has become horizontal. Okay, so again you can say that AB has been rotated 90 degree. So this confirms that angle of rotation of symmetry for a square is 90 degree. For a square is 90 degree. So in these steps you can understand that first you rotate it to angle, and then when you rotate it to 90 degree it becomes similar. Then again you rotate for certain angle, but again it becomes dissimilar as the first one. And after that, when you rotate it 90 degree to certain angle, so this and this again become similar, and you get the angle of rotation as 90 degree. So this is called as rotational symmetry, and angle of rotation here is 90 degree. Now we will further do the rotational symmetry in the next class. So I take your leave at this moment, and we would see that what are the other examples given to have a rotational symmetry. Have a nice day, students. Take care. Here I am explaining the part E and F of question number 12. So just have a look at it. The symmetrical lines given are horizontal and vertical and horizontal, and the figure is one step up, then one step inside, then two steps up, and then one step diagonally towards the line of symmetry. So for having a vertical symmetry, how would we draw? We would start with diagonal here. This is the first diagonal, then two step down just like this figure, then one step away from the line of symmetry, and then one step down. So by this you would get the overlapping in the horizontal direction. In the vertical direction, for the horizontal direction, we have to make number 1 same as number 3 same as number 1. So we would make one step down, one step towards the line of symmetry, then two steps down, and then the diagonal line which is touching the line of symmetry. Now for the fourth part, again if you overlap you should get the same as this, the third part. So we would start with first step down, then one step towards, then two steps down, and then one step diagonally. So this is how you get the symmetrical figure. Then this is the E part, and next is the F part. Again we have two lines of symmetry, vertical and horizontal. The figure given is let's draw the figure which is given to us. A diagonal, then one step down, then a diagonal. Diagonal means slanting height, and then a line joining the line of symmetry. Now to have a horizontal symmetry, like if you overlap this, fold the paper horizontally, then how should the figure look like? So we would start with, first is the diagonal line, then one step away from line of symmetry, so one step away, then it is going again away from line of symmetry, horizontal line of symmetry, so this, and then it is coming towards the vertical line of symmetry. So this is how you get the horizontal overlapping, same as the first, and this part becomes identical. Now coming to the vertical symmetry that we need to have. So we will look at the first part here. First the diagonal line, then one step up, then it is coming towards the diagonal, is coming towards the vertical line of symmetry. So we would make it diagonal like this, and sorry, just a minute, it would be, the diagonal line is opening up, so we would go like this, and then opening up means from this line it is going upwards. So here also from this step vertical we would go upward and then join to get the line of symmetry. Now for the fourth one, we would see the vertical line of symmetry. When you fold left right over the right side, then how you need to do it is, one step diagonally down, then one step down you get, then you have to move away from the, but towards the line of symmetry, and then the joining of the symmetry. So in this way, either you would have a vertical fold or you would have a horizontal fold, you would get the same overlapping, and this is the figure. So I hope you understand what has been told just now. So take care. Bye.